All right, continuing where we are, we've identified one-to-one functions. Now we're going to determine whether two functions are inverses. So the procedure to find an equation of an inverse of a function. So for a one-to-one function, to find y equals f of x, right? So f of x is our function. The equation of the inverse can be found by doing the following things. First, replace the f of x, that whole value, usually on the left, by y, which we know they're equal. And then, so you have y equals whatever with x's in it. And then what you do is you step two is to interchange the x and the y's. So where you have a y, it now becomes an x, and where you had x's, they become y's. Then you solve the equation for y. So now you have a new function, often looks different, but it doesn't necessarily have to, that says y equals something with terms of x's. And you then replace that y with the f inverse. So that's f with the looks like it's raised to the power of -1, but you can't really raise a function to a power. That doesn't work. You can raise a variable to a power, but not a function. So this is why this is the notation for inverse of a function. So this is f inverse of x, and that's the process. So here we have a function. We determine the function to be, we determine using that definition to determine if this function is one-to-one and whether the function is one-to-one. So first thing I do is I replace the f of x with y, which is equal to 3 of x squared. Then, not there, then I'm going to replace and switch, so this becomes x, and come on, stay up there. Where are they? That's not what I want. That's not what I want. There we go. I want my ink tools. All right, so, oh man. Okay, ink tools. All right, so then we're back to here. This becomes equal to 3. Ink tools, there we go. And this is y squared now. So now I'm solving for y. So I'm going to divide by 3. What color am I in? Yep. Divide by 3. Divide this side by 3. I now have x over 3 is equal to y squared. The way to undo that squaring is to square root both sides. So square root this and square root this. Then this becomes plus or minus. So this becomes y equals plus or minus the square root of x over 3. And then the last step is replace the y with, we'll just do it right here, f inverse equal to plus or minus the square root, oh, this is of x, better about that, of x over 3. Here's the thing. For an input, I have to get only one output. I can't get plus or minus an output. That means this isn't a function. So this here is not a function. Therefore, this is not one-to-one. So it's not one-to-one. So this one does not have a one-to-one function. let's check the next one. All right, so here we have this function. Again, same situation. I'm going to start by saying y equals, and I have negative 3x plus 1 over 3 plus x. Again, I'm going to replace switch out my variables, so this becomes x. And this equals minus 3 plus 1 over 3 plus, and put those changes in. So I have y and y. And now I'm supposed to solve this for y. So that's what the objective is. So we're going to solve this for y. So first thing, I'm going to multiply both sides by 3 plus y. And multiply this side by 3 plus y. Treating that 3 plus y as a single term. Then the great thing about that is that this cancels this. And on this side, I'm left with (3x plus x y) is equal to negative 3y plus 1. I want my y's on one side, so let me move this up here, and we'll work some more. So I have 3x plus xy equal to negative 3y plus 1. I'm going to add 3y and add 3y. This gives me 3x plus xy plus 3y is equal to 1. I'm going to minus my 3x because I want the x. I don't need that on this side. I just need y's on that side. X. So I now have xy plus 3y is equal to 1 minus 3x. All right, so now my y's are all on one side. So now I just need to isolate those y's and get them by themselves. So I can factor a y out of that, since I have a y in each one of those terms. So I'm going to pull a y out. I have y now. And inside, I still have everything I had. So I have x plus 3 is equal to 1 minus 3x. Again, same situation. I want to get the y by itself, so I'm going to divide by x plus 3. And divide this by x plus 3. That's x plus 3. That filters to 1, so I have y equal to 1 minus 3x over x plus 3. And what you may notice is, because the bottom is both positive, I could rewrite the bottom as 3 plus x. And if I'm careful with my signs, I could actually write the top as minus 3x plus 1. And again, I do need to, oops, not yet. I do need to replace the y with f inverse. So f inverse of x is negative 3x plus 1 over 3 plus x, which means this function is a inverse of itself. Now that doesn't usually happen, that we have one function be an inverse of itself. It just doesn't often happen. Not that it can't happen, just not often. If you consider the function, here's an example of one that's easy. If I consider the function f of x equal to x, right? So this would be a line going through the origin, and it has a slope of 1 over 1. So it's a positive slope. Well, this is its own inverse. It is its own inverse function. If I were to solve that for the inverse would also equal f inverse of x. It does happen, it just doesn't happen often. So this is this is a function. So because it is a function, we started with a function and we did our math correctly, our calculations correctly. This is our one-to-one inverse, and it is a function. So this one is a one-to-one. We're supposed to determine whether the function is one-to-one, and both of these functions are 1 to 1. And I say both, meaning this one and this one. And yes, I do know they actually came to be the same. That just makes them kind of a special one-to-one function, kind of like the one up here. So let's see what's next. If I recall, next is the, you guys get to do it. So again, try this on your own. If you have any questions, come into the Math Center, come see me before or after class, or Tatiana, and we'll guide you through the process if you need help. If you are trying this on your own, which you should be, please make sure to look back at the video, slow it down, look at it, pause it, etc. Just make sure you're okay. And then that will be, we found the inverses, and let's see. Then let's go ahead and just determine whether the two functions are inverses if we have two functions while we have the time. So determine whether two functions are inverses. We take one of the functions and we say that this other function is its inverse. We can compose those two functions. Again, this is going back to topic 3, I think it was, that we were doing these. Anyway, so the idea is that we compose the function. So if two functions are inverses of each other, then f composed with g of x is going to equal x for all values in the domain of g, and g composed with f of x is going to equal x for all values in the domain of f. So if we're just randomly given functions, we can compose them both ways, and you got to compose them both ways just to verify, but you compose them both ways, and if you get out x, it implies that this is going to be a one-to-one function, and we can determine that that is the case. So let's try some. So here we have two functions. We have f of x is equal to 3x plus 6. G of x is equal to 1/3 x minus 2. We're going to go ahead and put these together. And again, I'm going to start with f composed with g, for no real reason other than I just saw the f1 first. That's all. And this says I take my f of x function and I write, maybe this says I'm doing this. This is what it's saying I'm doing. So I'm doing f of g of x. So this is 3 and then parentheses. And then I'm going to plug in, come on. I'm going to plug in my g of x function, which is 1/3 x minus 2. And then I'm going to close that and then add plus 6. So that's what I have. I'm going to work with it now. I'm going to do some distribution of this. And remember, this has to distribute to both terms. Terms are separated by a plus or minus sign. So 3 times 1/3, well, the two 3's cancel each other, and I'm left with x. 3 times -2 is -6. And then we add 6. So this just equals x. That's great. That's what we were hoping to get. That does not mean that they're inverses yet. We have to check the other way. Sometimes things will imply inverseness, but they're really not. So we're gonna check it. This time we're gonna compose g composed with f of x. So this is g of f of x, which is 1/3, open a parenthesis, and then we'll plug in the f function, so 3x plus 6, and then we will close this and have -2. Again, same situation. I got to distribute this fraction to both terms. So 1/3 times 3x is just going to be x. 1/3 times 6 is 6 over, oops, dang it, 6 over 1/3, which is going to equal, wait, 6 over 3, which is going to equal +2, and then we have the -2, which is going to equal x. Because both ways give us the same result of x, not just the same value, but the x, which is what we expected, these two functions are one-to-one functions. So they are one-to-one, which is awesome. It's nice to know that they work. It's really something special for a function to be one-to-one, so this is pretty cool. Now, let's talk about what they look graphically. If we have this one-to-one function and we write an equation for the inverse, we can do that. Let me first start by saying that we expect some things to happen. I'm going to expect that I'm going to create a mirror along this line of this function. So I'm going to guess it's going to come something across one side. We're going to double check because that's what inverse functions do. They're mirrors of each other. So let's put these in. So first, let's see, this one's blue. I'll start with the blue and then we'll change it to the other color. So that's this one. So the first thing we do is we say y equals 2, not what I wanted, plus, come on, plus 1/2 x. And then we're going to switch things, right? That's the idea. So same situation, we're going to switch things. So now we have x equals 2 plus 1/2 y. Now I'm solving this for y. So I'm going to -2 x minus 2 is equal to 1/2 y. And again, I want the y by itself, so a way to undo that would be to multiply both sides by 2. So I'll multiply this side by 2 and this side by 2. This 2 will cancel the 1/2, and then this distributes to both terms. So I end up with 2x minus 4 is equal to y. And we want to change that. So my f inverse, right, I'm changing the y back to f inverse now, is equal to 2x minus 4. Well, we know from graphing that that means I go to my b, and this is in the form that we love to use for graphing. It should be like your go-to form is this y equals mx plus b. So that means b is -4, so I put a point here. And I'll do the points in black and then I'll draw the line in red. And my slope is 2, so that means I go up 2, 1, 2, and I go over to the right 1, and I put another point. And that should be, yep, my line. Let's see if I can draw this and make it semi-straight. I may actually put some more points in just to make it easier. So they go up 2 and over 1, and I'll put these in red. These are my extra points. They're not the ones I started with. Just so I can try to connect the dots and get a straight line. 2, there we go. So let's see if we can do this. So it goes something like that. And if that green line would have been right on, you'd see that if I put a mirror there, they're mirrors of each other. Inverse functions are mirrors of each other. They expect that sort of output, which means if we know the points, we could create an inverse function, or at least attempt to. So this is one way. We had to write the inverse function, which we've done. That's right here. And we graphed it right over here. So awesome. Let's continue. Here we're told to write an equation of an inverse function, but we're specifically looking for when x is positive, when it's greater than 0. So we do the same process, but because we're looking for just the positive, this will work for us. So again, y equals x squared plus 3. We replace them, so it's x equals y squared plus 3. We're going to minus 3, minus 3. X minus 3 is equal to y squared. The way to undo that is to square root it, which normally would be a problem for us, but when we square root this, we do not get a plus or minus, and that's because we're told this. We're told that it's only the positive, so this is always positive now. So this gives us that our y is equal to the square root x minus 3, which is really the same as saying f inverse of x is equal to the square root x minus 3. This is something we could graph. We know kind of what these look like. Let me see if I can, just a quick rough sketch. It doesn't have to be fancy here. I don't think I input one. So the first one, we'll do that in that same color, that red color, is x squared plus 3. So it starts up here and goes this way, and it goes this way, right? That's a nice function. We're only concerned with when x is positive, so we don't even need to worry about any of this, right? We don't even need to think about it. But it also means that when we graph our inverse function, that's going to look something like, well, about here, because that's a minus 3, like that. And we can see that they are mirrors if I had a nice line here. Again, we're ignoring the piece over here. We've said this doesn't exist over on this side, so no exist. We're only dealing with it positive, so we're really only looking at the graph from this side, right? So that's okay. And that is a nice function. Oh man, I put it on the graph. Did I put the whole thing? I did. Ooh, let me erase some of that. Let you see that a little better. That's okay. Erase. Okay. So again, my rough sketches, but let's, did that not work with the eraser? Let's try it again. Eraser. There we go, eraser. No, maybe it doesn't like that. Ink tools, eraser. I don't want to erase all. Nope, that's not what I want either. There we go. There we oops. Okay. So now you can see that. And then if I put that diagonal in, you can kind of see that it is a, now I can't get the diagonal to work. Great job. There we go. That it's a mirror of each other. Pretty cool. So there's a couple ways we can tell. Here we have a nice plot. And let's just put these in real quick. So what are these points? These points are positive 1, I'm at 4. So the point 1, 4. At negative 1, I'm at 2. Negative 1, I'm at 2. And at 1, 2, negative 3, I'm at 1. Negative 3, I'm at 1. And at negative 4, I'm at negative 2. Negative 4, negative 2. All right, so now we're going to plot its inverse. First thing, we need to figure out what those points would be. So really all we have to do is switch the x and the y's. So in our new function, it would be 4, 1, and 2, negative 1, and 1, negative 3, and negative 2, negative 4. All right, let's put these points on. So 4, so 4 is way out here, and then we go up 1, so up here. So we'll put a point. And then at 2, negative 1, 1, 2, negative 1, we have a point. And then at negative 3, no, at 1, we go down to negative 3, which is down here. And then at negative 2, 1, 2, we're down at negative 4, which is way down here. We try to connect these as best we can. And if we were to put a line there, we should be able to see that that looks like, there we go, and there we go. Looks good. So we've graphed the inverse function. Oh, I even have them in there. Oh, look, and even in the right places. And there's my line. Awesome. So that's the process. And there's one for you. Let you guys give that a try. Again, if you have questions, please bring it into either into the Math Center and get some help, or come in before or after class and we can talk about it, or into my office hours. Myself or Tatiana can talk to you about it. And there's where the line is. I hope I didn't put them in. I didn't. Great. And we've hit all the concepts. So the next one's going to be exponential functions. And what I will do is I will actually send a little, I'll post with all these links, a worksheet, not a worksheet, like a guide, rules of exponents, which apply to the rules of logarithms. So I'll give you both of them at the same time. All right. So that's it for now. I may do a few more before we meet on Wednesday, but this is all to help you get through all of this stuff before the exam next week, or week after next. Not this coming Wednesday, but the following Wednesday. All right. Keep working on it.